Gravitational field. The space around the body, that is the body, the space around the body up to which the force of attraction acts is called gravitational field. Magnetic field. The space around the magnet up to which force of attraction or repulsions act. Because in magnet, both forces are active. Because magnet has two poles, north pole positive and south pole negative. Electric field, the charge, the space around the charge up to which the force of attraction or repulsion act. It is clear? Now charge may be positive, charge may be negative. Now this gravitational field is helpful to the 12th class to explain the magnetic field and electric field. Here I am going to explain the gravitational field only. Now the body, the space around the body up to which the force of attraction acts, plays an important role. It extends up to infinity. Magnetic field extends up to infinity. Electric field extends up to infinity. But in actual practice, it is not fact, it is not correct, it is not true. The fact is that, the true is that, now the gravitational field has a certain limit. Magnetic field has a certain limit. And electric field also has a certain limit. Here, only the gravitational field is being discussed here. As the mass increases, gravitational field of this body, gravitational field of this body, gravitational field of this body. As mass increases, gravitational field increases. That means the gravitational field is dependent on the mass. Magnetic field is dependent on the pole strength, and electric field is dependent on the charge. In the case of gravitational field, mass of the body increases, gravitational field increases. In the case of magnet, pole strength increases, magnetic field increases. In the case of electrostatics, magnitude or a quantity of charge measured in the coulomb or a coulomb, the magnetic amount or a quantity of charge increases, electric field increases. But they have a certain limit. Gravitational field has a certain limit, magnetic field has a certain limit, electric field has a certain limit. But fact is that mass increases, gravitational field increases. Now it is clear from here. Gravitational field. Gravitational field of this body is greater than that of this body. Gravitational field of big body is greater, and gravitational field of the small body is smaller. Gravitational field here, now you can say a small body situated in the gravitational field of the big body. It is the big body. It is a small body. Now a small body is situated in the gravitational field of big body. But this big body is not situated in the gravitational field of the small body. We can understand like this. This is the America. Now the greater gravitational field, that is the Iraq. Iraq is situated in the gravitational field of the America. But this America is not situated in the gravitational field of the Piaz. Now a small body is situated in the gravitational field of the big body. Bangladesh is situated in the gravitational field of the America. I cannot say because I am Indian. India is not situated in the gravitational field of the America because the India is a big country. Therefore, giving the example of the small country, Iraq, Kuwait, Saudi Arabia, like such a country. And all the countries are situated in the gravitational field of America. Now the one-directional, unidirectional, one-sided process is being discussed here. Now a small body is situated in the gravitational field of America. This small body, Iraq, is attracted by the America. America is not attracted by the Iraq. Iraq experiences a force exerted by the big body. That I'm going to explain the intensity of gravitational field. Intensity of gravitational field or gravitational field intensity. In the 12th class, intensity of magnetic field, intensity of the electric field, now will be discussed in 12th class. Now here only the intensity of gravitational field is being discussed here. Now big body is America and a small body is Iraq. We are going to explain the intensity of gravitational field or gravitational field intensity. Gravitational field intensity. Gravitational field intensity is very, very important and helpful to the 12th class. Intensity of magnetic field, intensity of the electric field in 12th class. Here in the 11th class, it is the base for 12th class, concept for 12th class. Now here is the body. A small body, capital M, a small m, capital M is greater than a small m. O, distance R, that is the P. Now this is the America, and a small body is Iraq. Iraq is attracted by the America. Now America exerts force on Iraq, having the mass small m, and mass of the America is capital M, or there is a formation of the gravitational field due to the big body having the mass capital M, or this mass is called source mass. SOURC is source mass. Source mass is the mass due to which there is a formation of gravitational field. Source charge in electrostatics. Source charge is the charge due to which there is a formation of the electric field. Now we are the source mass. In gravitation, mass. Electrostatics, charge. 12th class, you will discuss in 12th class. Now the source mass is the mass due to which the gravitational field is produced, in which the small body of a small m is situated at r distance. And a small body is nothing but the Iraq. Iraq is a small country. And America is a big country. Capital M, mass of the America is greater than the mass of the Iraq. Now, America always exerts the force on Iraq. Iraq does not exert force on America. One-sided process is being discussed here. One-sided force in order to explain the intensity of the gravitational field. Now again, now the force on Iraq. Force on Iraq. Force, not force on M. Force on M due to capital M. Force on a small m due to capital M means force on a small body due to a weak body is a small capital M, capital G, a small m, capital M upon R square. F, G, a small m, following the Newton's law of gravitation. Newton's law of gravitational is the central point of this chapter. Now we are going to follow the Newton's law of gravitation. Now the m in the place of the m1, capital M in the place of m2, and the distance between the two body is a small r. But here now the force, now the America is exerting the force on the Iraq. The big body is exerting the force on the small body. A small body experiences a force. A small body feels, a small body experiences a force exerted by the big body. Iraq experiences a force exerted by the America. I think it is clear. Is it clear? Iraq feels a force exerted by America. Means a small body feels, a small body experiences a force exerted by big body. A small body here. A small body exerted a force. A small body experiences a force, not exerted. A small body having the mass small m experiences or feels a force exerted by the big body following the Newton's law of gravitation. But here the process is one-sided, not both-sided. Here one-sided, the process being now discussed here. Now America exert the force on Iraq. Big body exert the force on the small body, and a small body force on M due to capital M. F is equal to G capital M, M upon R square. Therefore, force on M mass. Force on M mass exerted by capital M. Force on M mass exerted by a small m, F equals is F. Force on M mass is capital F. Therefore, force on unit mass exerted by capital M, F upon M. Now the force on M mass, a small body of M mass experiences a capital F force. Therefore, the small body Iraq of unit mass experiences force F by M. Force on M mass exerted by the capital M is F. Therefore, the force on unit mass exerted by the F by M. This is the intensity of gravitational field. I equals F by M. I equals F by M. The intensity of gravitation may be defined as the force experienced by Iraq. Intensity of gravitational field may be defined as the force experienced by Iraq of unit mass in the gravitational field, and gravitational field formed by the America. Gravitational field formed by the America having the mass capital M. Now it is clear that the intensity of gravitational field or a field gravitational field intensity may be defined as the force experienced by the unit mass at a point in the gravitational field. Intensity of gravitational field may be defined as the force experienced by unit mass at any point in the gravitational field, not outside the field, but in the gravitational field made by the America, made by the big body. Now it is clear from now putting the value of F. Now here the putting the value of F. F equals I F G M capital M upon R square upon M. This is the second equation. Putting the value of F, intensity of gravitational field, intensity of, and M is cancelled. Therefore, I equals G M upon R square. That is the expression for intensity of gravitational field. There are two expressions. I equals F by M. I equals F by M. And I equals Gm upon R square. Properties. First, intensity of gravitational field is vector, which is directed toward the center of big body. It is vector, is directed towards the center of the big body. Second point, unit. SI unit of I. F by M. Newton per kg. Newton per kg is the unit of intensity of gravitational field, and Newton equals 1 kg meter per second square. Value of the N, kg meter per second square divided by M, not M, kg. Kg cancelled, meter per second square. A meter per second square is also the SI unit of the acceleration. And here now the SI unit of the intensity of gravitational field is also meter per second square. But it's not accelerated. Body is stationary. There is no question of the motion of the both bodies, whether a big body or a small body. Both are stationary. Only now the unit of the intensity, unit of intensity of the gravitational field is the unit of acceleration. Similarly, now the dimension of intensity dimension of I. I means intensity of gravitational field. The dimension of F, dimension of M. Now the first chapter of first units and dimension, you know very well the dimension or dimensional formula of the force. Now M L T minus 2 capital M cancel, therefore M0 L T minus 2 M0 M0, there is no meaning of M0. M0 means 1. LT minus 2. The dimension of the intensity of gravitational field is also is equal to the dimension of the acceleration here. Now gravitational potential. Gravitational potential. Gravitational potential, electrostatics, the third unit, magnetic effects of current, magnetic potential, and in the first unit of now the 12th class, electrostatics potential or electric potential. Now this gravitational potential is helpful to the magnetic potential and electric potential. For the explanation of the gravitational potential, there are three factors. First is mass is unit, means 1 kg. Second, from infinity. Third, inside the gravitational field. Gravitational field के अंदर, for example, here mass, the gravitational field of this body is the gravitational space. This space is the gravitational field of mass. This inside the gravitational field. Yani you have to follow. Gravitational potential is the work done in bringing unit mass from infinity to a point in the gravitational field, not outside the gravitational field. Inside, not outside. Three factors are important to explain the gravitational potential. Electric potential also may be defined like this. For the explanation, for the definition of electric potential, unit charge, work done in bringing the unit charge from infinity to a point in the electric field. I will discuss later on in the 12th class here. First of all, now the electric gravitational potential may be defined as the work done in bringing or moving or taking the unit mass from infinity to a point in the gravitational field, not outside, but inside the gravitational field. There are 3 points to explain the gravitational potential. Now, the gravitational potential may be defined as the work done in bringing unit mass from infinity to a point in the gravitational field. It is clear? Properties. First, properties. It is the work done. Gravitational potential is the work done in bringing the unit mass from the infinity to a point in the gravitational field. Work done. And work is a scalar, therefore the gravitational potential is also a scalar. Magnetic potential is a scalar. Electric potential is also a scalar. Because all are the work done in bringing unit charge. In the case of the electric potential, unit charge from infinity to a point in the electric field. Here only about basis, only the gravitational potential is to be centralized here. Gravitational potential may be defined as the work done in bringing unit mass from infinity to a point in the gravitational field. Work done, or work is a scalar, therefore gravitational potential is a scalar. Magnetic potential is a scalar. Electric or electrostatic potential is a scalar. Second point, the gravitational potential is zero at infinity. Body is situated at infinity, no work done. If the work is done, then we can define the potential. The body is situated at the infinity, no work done. Therefore, the gravitational potential is zero at infinity, but negative at any point in the gravitational field. The body has a certain gravitational field. Gravitational field has a certain limit. It does not extend to the infinity, but a certain limit. Therefore, now we can say that now the gravitational potential is zero at infinity, but negative at any point in the gravitational field. Why it is negative? I can explain tomorrow. Now here, negative. First, second, third. If the work done, if the W is the work done, W is the work done, is the bringing the M mass. W is the work done in bringing the M mass from infinity to a point. Therefore, the work done in unit mass, now W is the work done in bringing the M mass from infinity to a point in the gravitational field. Therefore, the work done, the bringing the unit mass equals W by M. M mass is W by M. That is the gravitational potential. W is the work done in bringing M mass from infinity to a point in the gravitational field. Therefore, the work done in unit mass, W by M, that is the gravitational potential W by M. Fourth, SI unit of V, W, joule per kg. SI unit of V. V means gravitational potential. And the last dimensional formula, fourth point, dimensional formula or dimension of V equals dimension of W, dimension of M. Dimensional formula or dimension of W is ml2 t minus 2, and dimension of mass m is cancelled, therefore m0 l2 t minus 2. The dimension or dimensional formula of the gravitational potential is m0 l2 t minus 2. Jai Hind.